So I'm just going to demonstrate the tool Mutability Detector with an example. So here we have a point class. It's fairly simple and it is also immutable. It cannot be changed after it's constructed. So how do we try and ensure that this point class remains immutable? Well, a Mutability Detector allows you to add an assertion, assert immutable the point class. We run the test for that and we see that the test passes. Now say at a later point in time a developer comes along, doesn't just want to get the x and y values out of this point, also wants to set the values. This could lead to some fairly subtle or hard to detect bugs. So he generates a set x or a set y method, runs the test again, and this time we see that the test fails. Expected point to be immutable is actually not immutable. The reasons being, there's a couple of reasons about the Java memory model, but the most obvious ones being that the field x can be reassigned within the method setX, and similarly for the field y. So here's an example where it's a stronger form of documentation than just adding an annotation or a comment in JavaDoc. A test failing is much more likely to be noticed. So another example could be another developer comes along and she realises that the point class should be immutable. So it's not a case of not realising it and enforcing the documentation. The developer in this case does realise, but she comes along, she doesn't want to be calling getX and getY anymore. She makes the choice that she wants to just be saying .x and .y rather than through the method calls. So she changes this class and accidentally does not add the final modifier, runs the test again, and we see it fail for a different reason, that the field is visible with the class and is not declared final. So somebody can construct the point class and call point.x equals say 42. So this is an example where the developer in question knows the class is supposed to be immutable, but has just made a simple mistake that otherwise wouldn't be caught. So with that class being mutable, let's see another example. Here we have a circle using the point as its centre. We have the same assertion, assert immutable for the circle class. We run the test for that, and it fails. Remember, point is currently mutable, and the test for the circle fails with the reason that the centre field can have a mutable type assigned to it, meaning that you can construct a circle with a given point and then later on change that point and therefore your circle changes. So if we go back and we roll back this point class to be immutable again, make sure it passes, we go to the circle, do the same, it now passes. It can now depend on point being immutable. So another example, we have another circle class. This time the point it depends on or uses for its centre is an interface rather than a concrete class. We have the same assertion here. Run the test again and it fails. The reason being this time is that the field can have an abstract type assigned to it. Therefore at runtime, when we're given an implementation of point, we don't know whether it's an immutable point, such as this implementation here, or a mutable point, such as this implementation. There's two ways to solve this. You could copy the relevant values from the given point into a known immutable class, and the test passes then. Or if your codebase uses the convention or the contract for the point that all its implementations must be immutable. That's not something that's expressed in the language, Java language. so that's not something that Mutability Detector can analyse. In this case, the test predictably fails, but here you can allow that particular reason for being mutable. So you can say assert instances of the circle class are immutable provided the point class is also immutable. So the tool is allowing you to say that there's something that you can't analyse as a static analysis tool, but I as a developer know. And here we can see the test passing. And with this particular reason being allowed, it will still catch other potential problems. So if we remove the final modifier from the radius field, run the test again, it will still fail. So it's only the particular reason that you want to allow that will keep your test passing. So this pattern where in the interface you define implementations must be immutable is quite common in the popular date and time library JodaTime. It's in some ways the inspiration for this allowed reasoning. So the circle and point classes that I've demonstrated here are fairly toy examples, but hopefully it demonstrates what Mutability Detector is capable of. You should also note that in all the examples there's been no extra configuration. All that's happened is that the Mutability Detector jar has been added to the class path, much the same way you would add, for instance, a JUnit jar, which would allow you to call assert false or assert true. Here we're allowing assert immutable.